Hi, my name is Shouq Alshahrani, and I'm going to be doing a comparison for the background initial microbiota found on surfaces of melons grown in different regions of the United States. So melons are a perishable commodity, meaning that they can't be stored for long periods of time without spoiling. Physical, microbial, and chemical spoilage does contribute to their low shelf life, so it's often recommended that you store melons in temperatures of 4 Celsius or under. Evaluating the initial microbial load is important for preserving quality and enhancing shelf life of melons. So we hypothesized that melons with a high initial load may have a low shelf life, and melons with a low initial load may have a higher shelf life, meaning that they'll be less prone to spoilage. So for our objective, we had to enumerate and compare the initial background microbiota load of different melons from different regions of the United States. So different varieties of melons from these different regions were shipped to Tucson, Arizona. These regions included North Carolina, Texas, California, and Arizona. In the lab, we used rinds from 2 different melons of each variety. So we cut them into 10-gram squares on a sterile cutting board using a sterile knife. The cutting board was vigorously sprayed with 70% ethanol and then left to air dry. The cut-up melon rinds were then placed in a bag with buffered peptone water before being stomached. Once the microbes were extracted from the melons, rinds into the solutions were made. We made dilutions and spread them into TCA plates. We enumerated the plates after 2 days. From Table 1, we compared the average initial background microbiota load selected from the selected varieties grown in different states. We had over 17 varieties of melon grown, and the number of varieties does differ between states. So some of the varieties that you might find in Arizona, you might not find in California, and vice versa. We also found that the total average initial microbiota load for the selected varieties between all the regions had no outliers. This suggests that the varieties couldn't have influenced the initial background microbiota, so it was, in this case, the environment of which the melons have been grown. We also found that melons grown in environments of high heat and low humidity had low initial background microbiota load. Therefore, these melons may have a higher shelf life. Melons grown in environments of low heat and high humidity may have higher initial background microbiota load and may have a low shelf life, meaning that they'll be less prone to spoilage. From Figure 1, we looked over the variation of initial microbiota between the regions using a box plot. So in general, when we look over at North Carolina, it had the highest average initial microbiota load, followed by Texas, California, and Arizona. In general, when comparing the regions, Arizona had the lowest minimum initial background microbiota load, while North Carolina had the highest minimum, maximum, and average between all of the states. North Carolina also had the highest initial microbiota load, followed by Texas, California, and Arizona. In general, Arizona had the lowest initial microbiota, potentially due to the extreme heat in which these melons have been grown in. In conclusion, being able to determine the initial background microbiota load can give us a better understanding of ways to develop methods in preserving quality and enhancing shelf life. Also, the environment of which the melons have been grown could also significantly affect the initial background microbiota and the shelf life, as we've seen from melons grown in Arizona compared to melons grown in North Carolina. The influence of the initial background microbiota load on melon shelf life needs to be evaluated in the future. This study was just done to help enhance our understanding of different ways the environment could influence the initial background microbiota. This study was supported by the USDA and IFA SCRI. So thank you.